Good morning. Let me see. I'm from the Boston area, and as you know, the Boston Marathon is coming up soon. So obviously you folks are all prepared for it. You clearly are endurance runners, made it through the whole ARC forum. So I want to welcome you for showing your persistence and coming forward here. My talk is going to be, once again, a little different than maybe some of the others you've seen. I'm going to focus on kind of I'll say the downside aspects, if you will. But before I do, let me start with the good news, if you will. And you may have heard this, you may hear more of it in this session today, you may have heard it elsewhere. Building automation systems, I'm going to go for a great definition of what they are. I assume that'll come up as well. But they provide all kinds of great benefits, as you see here. That's interesting, this monitor doesn't work anymore. That's okay. They provide greater energy efficiency, easier operation, improved occupancy. I actually read one report that claims that the employees are 37% more productive in a building automation system building. Okay, so there's a lot of great things about building automation, and it's increasing more and more. But they also represent enormous number and extensive opportunities for new cyber attacks. And as building automation systems become more widespread and cyber hackers become more aggressive, I often like to say, unfortunately, the worst is yet to come. So once again, I realize that many of you may be at the early stages of building automation, so I don't want to discourage you from doing it, but one of the things we've learned over the years from all of our research we've done in cybersecurity is one of the areas where you're most vulnerable is when a change is taking place. A new technology should be introduced, new procedures introduced, because you don't have 20 years, 40 years of experience. So all of the things you knew to be cautious about in the past, you haven't accumulated that. So you become more likely. So here's the other session here. Could you suffer a cyber attack? I don't know how many of you are in the building automation system industry? Okay, a few of you are. So I guess the obvious question is, one of the things we sometimes hear, and this also applies in operational technology in general and in factory automation systems as well. Often they say, well, I know all those terrible things going out there. I know there's a lot of bad neighborhoods, if you will, around. But we're in a safe neighborhood, primarily because we are air-gapped. But as many of you know, air-gap systems have been penetrated. Stuxnet probably was one of the earliest and most well-known examples of it. And so, and the second thing going on, and we see this in many of the other sessions you may have attended today, not just in building automation systems, but more and more there's need to connect to the internet. This is to allow you to do remote diagnostics, to allow you to integrate with your IT system for billing and for other purposes. It also allows the vendors who are providing more and more of the equipment to be able to monitor it. So more and more systems are not air-gapped, and even the ones that are air-gapped, there always are ways around it. So that's the obvious question I always ask people, do you think your systems are fully safe from being penetrated? Anybody? No. Now, once again, people may vary in their opinions. One thing, and I'm not sure if it was Larry or who I spoke to recently commented, that when you talk to people and they're honest about it, they say, well, there is a chance my system could be penetrated, could suffer a cyber attack. But what's interesting is often the second question and reaction was, well, what are you going to do if that happens? And usually there's like a blank expression because, I don't know, because we've never had to deal with that before. So the question is that you have to assume there is a chance, not guaranteed, there's a good chance that your system will suffer a cyber attack. So you have to change your mindset and say, let's assume that happened today. What is it you have to do? How do you deal with it? So I'm going to talk to you about some of those issues, if you will. The other issue I talk a lot about here, and I mentioned this in other people I met during the conference here, to my knowledge, and this is where I appreciate the other speakers may be commenting either now or during the panel session, there have been relatively few reported cyber attacks on building automation systems. This is a rhetorical question. Well, if you had a cyber attack on your system, why wouldn't you report it? Why wouldn't you make it public? Well, there's lots of reasons. The first reason I was told is you ask the lawyers, they say nothing, is the first advice you get from every single lawyer. But also you don't want to suffer reputation damage. You don't want to encourage copycats. You don't want to deal with all the legal complications that come out of announcing you've had a cyber attack. So the problem is getting detailed information on when cyber attacks happen, how they happen, what were the consequences, what people dealt with them is very difficult. I'm going to give you a little bit of information I've been able to gather, and hopefully many of you here could either share or contact me either here or afterward to give me more stories about it. Most of the reports that I have seen, I'll comment upon some of them today, are reports done by white hats. That is basically good guys who want to see, is your system secure? Let me go and rattle this, let me go and rattle that, and see what I can find. So in general, these are not such a real cyber attacks, but basically they have all the kind of key elements of a cyber attack. And of course, once this vulnerability has been discovered, hopefully soon, which can be measured in hours, days, weeks, sometimes years, that vulnerability will be patched and life goes on. So let me give you a few examples. One of my favorite examples, and once again, I appreciate my colleagues who have more knowledge than me. Allegedly, this is a hoax. It was not a real cyber attack, but it was reported. You can find it on TikTok if you want to. It's basically made a large office building into the world's largest video game. I'm not sure if you can see it here now. Basically, this is Space Invaders on a 20-story building. You know, you can see the bullets coming down and the shooters here and all that sort of stuff. Now, whether that actually happened or not, it technologically is possible to happen. If you take control of the lighting system for a building and you hook it up so you can remotely control it, you can control the individual. In fact, in the video, they actually show people at the window as the lights are going on and off. And once again, I'm not sure if it's a real event or not, but it illustrates the kinds of things. Not exactly the most destructive thing. Obviously, if you're trying to work on getting your annual report out and your lights are going on and off as the bullets pass by, that could be a bit distracting. Once again, done by a white hat, but this was an actual validated attack. There are many basically smart lighting systems of all various kinds. This would happen to be the Philips lighting system. And they showed how, what's clever about this, they combined a number of technologies. They actually had the cyber attack, because they had to be physically close to do this particular attack, but they actually had a drone fly from a mile away to the building, take control of the lighting system in the building, and basically turn it off. They were not clever enough to make it into a video game, so it's nowhere near as interesting a video to see. You just see lights flashing on and off more or less randomly. Not exactly building automation per se, but has a lot of the same characteristics, was it? I'm going from 2009 to 2016 to 2020, so these things keep going on and on. This was also a demonstrated cyber attack on the traffic lights within a city. So not exactly within the building, but the same kind of ideas. And it was kind of something I would really like. Not only could they turn the lights on and off, they could also time them so you get a green light all the time. That is a feature I wouldn't mind putting, having availability yet, if anybody's been through any kind of municipality, if you will. So those are some examples I've seen. Let me open for a second. Any of my colleagues here, anybody else, seen other examples of real live cyber attacks on buildings? Before I go on. Yes, go ahead.
I don't know if it's a building, but you know, the target hack went in through the HVAC
Yeah.
system and laterally hit customers.
Exactly. The reason I wouldn't count that is because it really wasn't attacked on the building automation system. It was a case where they leaped, if you will, from the building automation system into the IT system. So it definitely, you know, in the broad scheme of things, it has that connection. But let me give you some I have come across. This is fairly recent. This is 2022. Cyber attackers took control of the lights, basically took control of the total building automation system, including the heating, the door locks in an office building. But let me do a quick digression, because I guess it would fall in a category of building automation, of much more limited. I believe I have not actually used the feature. In this hotel, I believe you can unlock your door from your smartphone. I know I've used that feature in the Hilton in New York City. I think it was like 3 years back, there was a hotel in Austria that suffered a cyber attack. And the cyber attacker changed the lock settings on all of the doors. Now, the good news is you can still use the handle like you can here to get out. You just couldn't get back into your room. What was interesting, this now was 2 or 3 years ago, so I haven't seen the latest, but apparently in the aftermath of that, he switched back to manual keys in the hotel. So that's a case where someone said to me, the cavemen never suffered cyber attacks. So there's a question of how far back to the caveman age do we have to go to be fully safe. And what it shows here, this is some direct quotes. A technician called us telling us this was the building automation system company, got a call from one of the managers of the building. So the technician told us his building was completely locked down and he couldn't operate it. It even locked the building owners out. Now what happened here was there were certain features, and once again, maybe some of you know more about all the various features, but there's various features you can have in the building automation system to basically not allow updates to take place for it, or not allow change to take place unless you have a secondary password. But apparently they had never bothered setting that secondary password. But the hackers did. So now when they tried to regain control of the building automation system, they were shut out by the protection features that they had put into the system to potentially hackers prevented the owners from getting into their own system. I'm not sure if I gave the story completely straight, but just to give you an illustration of how things can get out of control. And what I just did. Okay. And I just came across an article recently about 2 buildings being hit in Finland. I don't have the details of those buildings being hit. So there are actual cyber attacks taking place. Once again, why are not more of them? Well, first, we don't know how many are actually being taken because they're not much reported. And secondly, if you will, there's what I call the low-hanging fruit. If you can steal a credit card number and make money off it, why not? Why not? But it turns out, as you've seen, the classic example I gave was the Colonial Pipeline executive who testified in Congress saying, well, we had never considered the possibility that someone would do a ransomware attack on Colonial Pipeline. That's like a building automation system company saying, well, I never considered the possibility of someone doing it so far. So these are kind of, maybe it won't happen today, maybe it won't happen tomorrow, but basically as they work their way down the opportunities to gain money, it's just yet another target waiting to be hit. Now, let me share you a little bit of research we're doing at MIT. And this is, I will not say we're doing a lot. That's why I'm anxious to learn more when I come to these conferences, if you will. But we are working with some of the standards groups on building automation systems and building management systems, particularly those who are interested in doing energy management, improving the energy efficiency. In this case happens to be apartment buildings they were looking at. What was interesting about this, we talked about cyber attacks in terms of disrupting things, but also they can be used as a way to deal with or invade your privacy. And this is an example of what they were able to do. They were able to tap in, once again, this is all done by white hats, so this was not an actual external cyber attack. They were able to tap into the energy management system of the building and looked at things. So for example, that there, I'm not sure what time of day it was, but that's you preparing your smoothie for breakfast with the blender. And over there you can see you're starting working. Imagine your boss having access to say, whoa, you said you were working at 9 o'clock this morning. You didn't turn your workstation on until 11 a.m. this morning. What were you doing those 2 hours? I see you had a long smoothie break. So the possibility of, in some sense, getting an awful lot of information of what's going on either at your desk, in your office, or at your home. Once again, good side, bad side, the energy management feature could take advantage of this to plan better, to know the better view of your energy demand. So there's a lot of, almost everything is a double-sided coin. Almost everything can be used in a very beneficial way, both to you and to your company and to the building, but also, if abused, could be invasive of your privacy. Another issue here is the issue of how bad can it really get? And this is my point I mentioned. If you take the assumption that, yes, you could be hacked. We don't know when, we don't know how, you could be hacked. How bad can it be? Well, if you shut down an organization, whether it be an apartment building or office buildings, building management system, that can be very disruptive. If the lights are all off in your offices, you can't get a lot of work done, particularly if you don't have enough sunlight coming in through. But it's really serious. I mean, I worry a little bit elevators, but I think elevators have kind of a mechanical brake on them, if you will. So I don't think you can say plummet you to the bottom. So most of these things can be disruptive, if you will, but nobody really gets hurt. But is that really the end of the story? Well, for one thing, of course, if the disruption lasted more than a few hours or a day or so, your business basically is shut down, you have to go someplace else, that could be very costly to you. But can things really blow up? Can people get hurt? Well, this is some of the area, once again, I work with a lot of different groups at MIT, the aerospace department, the power systems people. So we work with them on various experiments. So this is some of the things I want to talk about. How many of you are familiar with variable frequency drives? I wasn't. I'm glad to see you were too at one time, but I've learned a bit, if you will. So as you know, these are controllers that basically allow you to control the speed of a motor electronically, if you will. And of course, they're used in all kinds of systems, but particularly in building automation systems. They exist because they're often used to control pumps and fans. They're a key component with HVAC systems and so on. But most of the modern VFDs, or the VFDs today, are usually operating under software and firmware control. And we've actually looked at some of the software and firmware controlling VFDs. So here's one of the projects we did with some of our students, if you will. This is a typical VFD that they use in the power systems lab, where they allow them to play around with it and test and try various different things. I usually say the size of a bread box, but I don't know how many people have bread boxes in their houses anymore. But in any case, you can imagine, it's a relatively small system, and it has these various capacitors. Typically, VFDs have series capacitors. We changed a few lines of code, which you could change, assuming you have access to the firmware of it, which you could have if you manage to breach into the system. And this is what it did. Now, we did it outside, okay? And this is an explosion outside of the power systems lab, section, if you will. Now, that was a toy VFD. What do real VFDs look like? Well, they come in all shapes and sizes. This is one shape and size. Someone actually offered to donate one to us, and someone was interested, would you want to explode it? We say, I don't know if I want to be anywhere near if I did. So we haven't done it. We don't know how big a mess it would make. Maybe someone have seen one of those go. But if you were to do the same kind of thing, change the software controls, do the various things that we did with that small test system, you could get a pretty messy situation. So that's kind of the concern I have. Now I want to kind of do one last thing before I end my talk today. Some of you may have heard me give this pitch before, if you will. We've developed an approach to analyze these types of systems we call cyber safety. And it's a clever term because cybersecurity is kind of almost overused. Cyber safety kind of combines the notion of being safe with your cyber, but it actually is very different. Safety, in most cases, is to prevent accidents from happening. And accidents are, hate to say the word, accidental. They're happenstance. And so the odds of an accident happening is, whatever the statistical probabilities are. But if it's done by a cyber attack, it can be deliberate. And when it happens and how it happens can be much more controlled, in this case, by the bad guys. So we want to study how do you analyze possible cyber threats. The approach we had is, number one, of course, was make sure you understand what you're trying to prevent. Like, I don't want this thing to explode. You'd be very clear about what your goal is. Then you say, and this is, I often made the comment, in the headlines, you'll often see the headlines say, this should not have happened. Well, then what is it that you would put in place to ensure that it did not? What controls did you put in place? So we say that everything that happens in your organization, including the firmware on the VFDs, but everything in your organization, whether it be computerized, mechanical, human activity, is a process. And for every process, there should be some controller that's monitoring the process to make sure it's behaving correctly. But that controller, if you will, is also a process, and there should be something that is monitoring that controller to make sure it's behaving. So we call this hierarchical control process in an organization. I won't go through all the details of how we use this analysis, but basically we developed this we call hierarchical control structure. To give you one last example, we decided to look at somewhat of a system that you would imagine finding within a building automation system controlling, and that is chiller systems. Because chiller systems, obviously to keep things nice and cool, sometimes a little too cool in this room, are fine. It turns out they're becoming increasingly important because many companies have data centers. And keeping your data center cool is a very, very important issue. Otherwise, your data center goes down, which is all kinds of other complications. So we wanted to see, what kind of vulnerabilities could we find in a building chiller system, if you will. And so we developed a hierarchical control structure for it. Once again, the print's too small to read. I don't encourage you to do so. But the point being, we said, what are all the processes? What are all the controllers? What are the controllers for the controllers, et cetera, et cetera, et cetera. a level of detail that a lot of people don't really go into, if you will. And if, for example, there's all kinds of things we came up with. For example, one of the things, as you probably all know, many devices that have motors in them, there are certain resonant frequencies. And what you do is you build your system, particularly in the software, to make sure you avoid the resonant frequencies so you don't shake themselves to pieces. Or if you kind of flip the software around, and rather than avoiding the resonant frequencies, you target the resonant frequencies, very messy things can happen. Likewise, if you reverse the rotation, various bad things can happen because many systems, once again, the VFDs can go backwards, but maybe that wasn't what they were designed to do, and the consequence of what the pumping is going on can be very bad. Also, you have to control certain settings in terms of pressure, in terms of temperature. If the lubricating oil isn't at the right pressure, the right temperature, it says, I've been told it can basically damage and destroy the compressor within minutes, and so on. So in case just going back one notch here, you may have noticed at the bottom, VFD explosion. We've already been there already, but you understand that idea. So the point we're saying was there are many different vulnerabilities within a chiller system. Once again, as white hats, we didn't try to blow up any chiller systems, if you will, but we basically demonstrated what would be the vulnerabilities that could do that happen. And we developed various attack scenarios over here of how you could override various parts of the control system and cause it to go basically off the wheels. Those are interesting. There's a paper we wrote and published about how to basically blow up chiller systems if you happen to be bored someday and you kind of want to give it a try, if you will. And some conclusions. In some sense, as I've said at the very beginning, and I'm sure many of you probably are here because you either are involved in or considering it, building automation systems have enormous advantages. I'm not the salesman. I'm sure they can tell you all the benefits, enormous benefits. But they do present all kinds of new opportunities, both good opportunities, but also dangers. They've been infrequent so far, but they're likely to increase as time goes on. So as you're considering and designing, building automation systems, you also have to keep in mind what are the possible things you need to be careful about. So those are some of the things that we want to discover, and I'd be glad to answer more questions probably during the panel session. I want my colleagues to get up and have their speech. Thank you.
Thanks, Larry. Good morning, everybody. Excited to be here and have an opportunity to talk about, I think, one of the most important topics in achieving our sustainability goals, which is the connection between data and achieving decarbonization. I'll start with this premise that data is fundamental to everything we need to do to address sustainability goals. It is a cross-cutting, if you will, resource for all of the types of systems and goals that we have out there. So let's talk about some of the use cases in the built environment, making that a little wider than building automation, like the built environment would include street lights, those types of things, right? But here are some use cases that rely on data, and importantly, they rely on data from multiple sources, which is really one of the fundamental points of this conversation here today. If I want to maintain optimum efficiency of building systems, I'm going to need data. I'm going to need data to do fault detection and diagnostics. I'm going to need data during the commissioning and monitoring and verification processes. Those are data-driven. If I want to integrate alternative energy resources into buildings and also integrate them into the grid, building to grid, which is an important part of the future of our grid, vehicles to grid, et cetera, I need data to do all of that. In fact, the integration of the data is more complex than the integration of the networks, if you will, to get the data, right? And then when we want to optimize the use of different energy resources, that is a data-driven process, right? I think for the past, my experience of 35 plus years, we were looking to reduce energy. We might actually want to use more energy if we can use it from an alternative energy source. So the analyses now become much more complex of why I might want to switch between different energy resources. So in order to support these and other use cases, we have to be able to use data, and it comes from diverse sources, which leads to a very big problem, all right? Building automation systems with the equipment themselves produce a wealth of data. But most of the data produced by these systems has very poor, limited descriptive information about what it is, all right? You have diverse communication protocols, literally hundreds. You have diverse data formats, and you have diverse or non-existent data models about what the data means from an individual device or system. And one of the challenges has been there hasn't been a standardized approach to data modeling or semantics, right? There are numerous standard protocols, but this one models data this way, this one models it another way, this one models it another way. I have data in a database, it's modeled another way, I have CSV files. It's bigger than the communication protocols or buses out there. And one of the key points we like to make is, names can't do the job. Well, if we just standardize on a naming convention, right? Okay, well, that can't do the job, and I'll give you a quick example. My name is John Petsy. What does that tell you about me? Height, weight, where I live, nothing. All of those things would be attributes of me, right? Now, my credit card company stores those attributes in one format and another format and all of those different things, right? But if we want to bring together these systems to the operation of the built environment, it really helped to have a standard data format, okay? And what we're seeing now as we do these integration projects to accomplish the goals we talked about, fault detection, commissioning, integration, they're being delayed, and there's great resistance because there's a manual, labor-intensive process to do this manually, to get Larry's data set and figure out what the heck it means, and to get your data set and your data set and to try to figure this all out manually. It's called data wrangling, data mapping. A variety of four-letter word terms are often used during the process as well. But we can't create value until we can get through this part of the process. And one of the frustrating things for owners and operators who want to get these benefits is it's invisible to them and doesn't really make any sense. Because, in our world, right, I pick up my phone and I get data. I don't think about this problem. But in the world of building systems, it's a fundamental problem, and it forms a big barrier to the efficient use of data. Can the data be used? Absolutely, but if it's at too great a cost, then we're not going to do those things to improve the performance of the built environment. So here's a kind of a graphic representation of the challenge. The building systems produce, on the left, diverse, multi-structured device data with a lot of information or literally zero information about what it means, okay? And it comes across different protocols, right? And at the end, what we would like is to have uniform, standard model data so that I could take data and understand what it means and do something useful with it. Well, that's what Project Haystack is about. It's a standardized approach to make data from diverse systems easy to work with, interoperable, normalized, contextualized. Project Haystack was founded in 2011. It's an open source 501c trade association. We'll talk more about that at the end, but let's talk about what it accomplishes first, okay? The concepts were modeled after work being done in the, on the web, the semantic web, et cetera, and it's built around a core concept of tags. Think of them as attributes. I can add tags to data that I get from a different system to describe what it means. Most basic would be units, right? One of the things I like to say out here is, do you know that numbers have no meaning? Larry, I'm going to give you 100 after this session. Lashes, right? Numbers have no meaning without units, and we all use units so much, sometimes we don't think about it, but numbers are meaningless, okay? Well, that's an example of an attribute. And in the Haystack methodology, it's a tag. We have the tag for units, okay? Tags work together, though. There's a library of standardized tags, so we should all use the same tags, but they work together within a larger data modeling approach so that we can describe systems, devices, interrelationships, et cetera. That's all part of what Haystack's been working on for over a decade. So we're going to transform what we call raw data, because it comes from different devices, into a uniform and self-describing format. And I like to use an analogy that we all live with every day. I think of it as a markup language for data, okay? Why can I point my browser at your website and read what you published? Did we get our engineers together last week and said, hey, we're going to need to know the API because I want to read what you published? And of course the answer is no. Because long ago, in the world of the information web, we agreed on an approach, a standardized approach to mark up text, pictures, all of that data. It's called HTML. Without that, we wouldn't have the easy-to-use, efficient web that we all are dependent on now, right? If you use HTML, I can read your website. We didn't have to predefine anything. I remember back in the early days when people weren't all using the standard of HTML, and you'd go to a website and you couldn't read it, right? Very early days. Well, think about Haystack doing the same thing, but for device and equipment data. Model your data with these approaches, with this methodology, and someone else is going to be able to consume it without the manual, extensive effort. So, there's really some core concepts to the whole idea of data semantics and what the Haystack organization has done. First, you have a vocabulary, standardized terms that you will use for all the common phenomena that you have out there or ways you want to describe things. And this is a worldwide open source organization, and birds of a feather come together who are experts in different systems and say, here are what those systems are made of. Here's the proposal for the tags we'll use. It goes to review, and then it's published, okay? But beyond the vocabulary is the taxonomy. We want to create a hierarchy, so we want to have a modeling approach so that we can create a hierarchy or a taxonomy of the different systems, right? With the end goal of achieving an ontology that shows the relationships, so that we understand the relationship between a fan and an air temperature that might be on the other side of the building that is on the air being produced by that fan, the relationships, okay? And so by utilizing this approach, we can effectively create data that can be easily used. All right. So what does it enable? Why is this important to people, right? Well, in the world of building system, it allows other applications to use that data without the people who want to use it being expert in the actual system. They can get the data and say, I want to analyze high and low temperatures in office buildings. I don't really know anything about chillers or boilers. That's my project. They shouldn't have to have deep domain knowledge to be able to look at temperatures, right? Or to look at what's the average energy consumption or demand peaks on hot days or whatever, right? So that's really important because it frees the data to be used to help society in general achieve sustainability and decarbonization goals without saying, oh, you want to work with automation data? Well, come back in 10 years after you know everything about automation systems and maybe you'll have a hope, right? And we like to say making applications that just work. And here's some quick examples. Digital twins. If we can read the data out of those equipment systems, you can auto-generate the digital twin, okay? All right. Digital twins are great once they're done, but the work effort to get there when you're trying to bring diverse systems together is often the barrier to even considering to use a digital twin. What if I can just read that data out with all the semantics and boom, I have the digital twin, okay? Here's another example, control logic that finds the devices it's supposed to control. You might have hundreds of fan coil units in a hotel or VAV boxes. What if I have a really optimized control sequence, but I don't want to sit down and attach it or program it or link it to every one of those pieces of equipment? Well, with semantics, basically that control sequence can find all of its targets, okay? That makes it easier to apply these optimized control algorithms that might be driven by machine learning or other AI techniques, right? Hey, I got a great machine learning algorithm that'll optimize your hotel. Wow, that's really good. Yeah, it'll just take 17 weeks to apply it to 1,000 room controllers. Yeah, that won't fly financially. But what if it takes, press a button? Okay. And it also helps with a new generation of engineering tools to streamline the process of implementing all of these different systems and connecting them together. Okay. So we like to say that this is the goal of the Project Haystack organization, is to enable a future where you can push a button and turn that device data into true intelligence and value. So now I'll just offer a little bit of background on the organization and make a claim I like to make to get everybody thinking. Do you know that the data produced by a device is now worth more than the device? And people thinking, well, wait a minute, that room controller unit, that costs $500. Run it wrong for a year. You'll spend more than $500. Well, a chiller, that's $200,000. Run it wrong for a month. You'll burn up $200,000, right? So this is why this initiative and what society needs to do with data is so important. The data is actually more valuable than the capital equipment, okay? It's the only way we're going to make the built environment smarter. It's the only way that we're going to be able to bring these systems together to get efficiency and obviously move towards sustainability, right? And that's really what this standardized approach to data modeling does. And it's at the data layer. So you could have data that's in an Excel spreadsheet, in a database, coming off of OPC UA, coming from MQTT. This is at the data layer. There's lots of effort to standardize the protocol layer, and that's great, right? There's a great cartoon that I'm sure a lot of you have seen, right? Oh, look at all of these standard protocols, but none of them solve my problem. We need a new standard, and now we got yet another, right? Well, what we need is to have a way above that to contextualize the data independent of how it came in. So the benefits extend across the entire value chain, from the owner-operator to the facility managers, to the system integrators who are installing systems, and even the OEMs who produce equipment. And the reason we have this slide, and often do this, is to help in our educational efforts to show there are benefits to you, Mr. Owner, from specifying or requiring that the new systems installed adhere to this standard, provide the data in this standard way. Because a lot of time owners go, well, the contractor's going to charge me more if I tell him he has to contextualize all the data with Project Haystack, right? Well, there are benefits directly to you as the owner-operator. All right, so data needs meaning to be useful. I think that's a pretty obvious thing, especially to this group here, because it supports being able to interpret the meaning of data, to be able to determine what data you need for a specific goal. Talked about identifying goals. What data do you need to evaluate those safety or those security issues, right? And this semantic tagging approach and this worldwide standards community working to solve this helps us achieve those goals. So a little bit about on the background. It's an open source, completely open source. There are no costs to use any of the work. You can go to the site and download every bit of work that's ever been produced in over a decade of the organization. It's a 501c to run the organization. Community-driven process, driven by working groups or people who get together and say, I understand electrical distribution patterns, ground source heat pumps, variable refrigeration, flow systems, et cetera. So much complexity out there, you have to have working groups who understand it. One exciting step for the organization was to get Department of Energy funding, won an award for a 3-year program that started at the beginning of 2022 to create validation tools so that people could say, can verify that their systems have been properly tagged, if you will, so that it gives people confidence. And that project is now coming up on 1.5 years of the 3-year cycle funded by Department of Energy. Growing corporate membership. We have our board members considered founding members. We have associate members, but any individual can just sign up, get an account, participate, no cost. There's no individual fees to be a part of the organization. These organizations on the right, they do it to help. They want to see this effort move forward so that we eliminate the friction and unnecessary cost in achieving these end goals and making our built environment more efficient. Lots of case studies that span from highly technical to the commentary of engineering firms and owners and operators of why this is important to them. The organization publishes a magazine twice a year with lots of examples. Reference implementations in numerous software languages, programming languages out there, all contributed by the community open source. You can find them at project-haystack.org, wealth of information. Whoops. And you, just example of case studies. One of the things the organization does is it hosts a live event every other year. COVID caused us to move to virtual, but next year we're going back to in-person, where the whole community comes together, like we're doing here, but with a focus around data semantics and moving this all forward. And 2023 will be in Nashville. So with that, key takeaways: this is real, this is deployed, it's in tens of thousands of buildings, completely open source, zero cost to use any of the technology, including reference implementations in different software, programming languages, etc. And this is key. The methodology is extensible, right? So you can say, well, you know what? I have a building that has systems that the group hasn't standardized the tagging on. You can use that methodology and create your own vocabulary that can still be read by another application, right? You may need some final interpretation, but you can extend this to even applications that haven't been addressed by working groups, and that's key. It's also super lightweight. You can put this in temperature sensors, okay? And interestingly enough, it's human readable and machine readable. So, technicians, when they implement systems, they're often sitting on a white plastic bucket, on a keypad or keyboard trying to set stuff up, and they're thinking about the reality of the equipment in front of them. This stuff's readable by human beings, which is a very interesting thing, because that we came out of the implementation side, right? So it's understandable by real users and is a successful approach to solving data semantics. So with that, thanks.
Well, thank you for the opportunity to get to talk today, and I've enjoyed the first two presentations. I've learned a lot, and some things that even as I get ready to do my presentation, I would probably incorporate things that I learned today. My name is Russ Parrish. I'm based here and just outside of Tampa, Florida. I work for JLL Technologies, and you might say the corporate real estate world. How does that play into this? And about 15 years ago, I got first involved in this industry. Before that, I was an electrician. I was in the Navy, got into manufacturing, and the world of energy and sustainability opened a door into corporate real estate. And I've got to do a lot of cool things since then. One of the very interesting things, and my topic today is on optimizing building operations, right? And so that does center around building management systems. That does center around data. And a lot of other aspects. So what I do for JLL is I manage several of their technology platforms. I lead them globally, whether it be CMMS systems, procurement type groups, and things of that nature. And I have an extensive engineering background. But the cool part about getting to work with JLL, JLLT, is I get to straddle a number of fences. So being a corporate real estate, we're involved in just about every business you can think of. We're in healthcare. We're in, basic building management that you think of when you think of corporate real estate, data centers, pharmaceuticals, retail. I manage 700 different clients on one of my platforms, and they range from, a Wendy's franchise all the way up to companies inside the Fortune 10. And so a little bit of everything in between. What that means is I've seen a lot of good things, I've seen a lot of bad things, and there's a lot of different ways to approach projects. And so what we're going to talk about today is kind of a holistic approach and things you need to think about as you're working through optimizing your building using your building automation system. That's the wrong button. That's the right one. So we're going to kind of begin with laying the foundation, right? There's a project, there's something I need to do. I kind of treat this more programmatically. So there's a lot of things you need to be aware of, a lot of things you need to put in place to begin that. And so we're going to kind of figure out where we are in the life cycle, and then what's the solution. So we live in a digital age, and it's very exciting, and it's very rapidly changing. The cool thing about that as well is that not everybody's at the same point, and they don't do the same thing. So the digital world allows a great amount of flexibility, a great amount of freedom, but there's also standardization, as John was kind of alluding to with data, that we have to kind of adhere to. So again, in the JLL world, we get to do a little bit of all of that. And we have customers that are on different, various points in the journey as well on their own digitalization growth, digitalization, digital business. Buildings themselves. I keep looking back, I forgot this one was on. have evolved, right? And that's the other part is, we had disparate systems, everything, with information that it gave us, but it never was tied together, and there was operations and all of those. In the building management system world, you can do a lot of these functions and activities. Obviously, we came to the connected side where we have all of our systems tied together, they're communicating somewhat, and there's also information that's flowing. Now, again, John touched on the point that just because you have information and data doesn't mean it's useful. And that's still a lot of the same application. To all the way to the smart, interface buildings and operations, where now not only are we able to communicate, we're able to control, we're able to change, we're able to evolve and tie those together. So again, a lot of people are still in all three of those. They may be straddling the fence between one, two, or all three. And again, as we begin to talk about a programmatic approach, you need to begin to lay the foundation, but the foundation has to be such that where am I going to be a year from now, 3 years from now, 5 years from now? What is it that I really want to accomplish by doing whatever it is I'm about to do? And so the playing field, there's a ton of different things out there that provide us information that we could use. There's a ton of different players, all of them good, all of them with aspects that they bring to the table specific to their specific piece of equipment. But then you have to begin to tie those together. Again, this is where I'm starting from. And the aspect of I have a blank sheet of paper and I get to begin isn't usually there. If it is, that's the best time to do all of these activities, because you can lay out the way you want it to go, you can lay that foundation, and you've got the results exactly. You're going to have to overcome things based on the number of inputs that you're taking from, like I said, those disparate systems. And then we're going to talk a little bit, I'm going to do a little bit of a case study on a project we did with IntelliCommand. And, it's a commissioning platform that we use. We've had a partnership for 4 or 5 years with them now. And it kind of builds on the machine learning, AI aspect, auto fault detection, and different aspects of that to actually optimize and get the peak performance out of your building and your systems. So it's very interesting. Why do we do it? All right, so I'll tell you right up front, I'm a reliability engineer by trade. So we're going to incorporate the maintenance and engineering aspects of this as part of our program. And as a reliability engineer, we want to do the right work at the right time, at the right cost, with the appropriate risk, right? That's the driving force behind sustainability, energy conversion, all of the things that we're kind of talking about and tying together in these systems. You're never going to get rid of all the risk unless you have very deep pockets. I've worked with a variety of clients and jobs in my career. I will tell you, one of my jobs was I got to run the data centers for the New York Stock Exchange. You would think they would invest everything they had and would have a perfect record. Well, no, they don't. And so there's always going to be some risk involved in what you do. This is a definition of world-class maintenance, and there's about 30 years of data behind this. The other thing is everybody kind of has their own definitions of what they're trying to achieve, but you need to define it. That goal needs to be out there, and it needs to be ever-changing as you continue to work through the process. The bottom line numbers there talk about being reactive versus proactive. And as you look at the companies you work with, or the companies you go into, or your company, how reactive are you to things? We talked about cybersecurity. There's a cybersecurity attack, everything about that's going to be reactive, even if you've got the best systems in the world in place. Having worked with people that have had ransomware attacks, the effect is immediate and the effect is long-term, right? So you lose work, you lose data, you lose things that you'll never be able to recover. Yet you have to build and recover as best you can, right? And that takes time, money, and effort. So in this case, they talk about reactive versus proactive, and it takes 3 times longer and costs you 4 to 10 times as much to do the same job. So your goal in this exercise is to shift as proactive as you can, just like mitigating that risk. Mitigate as much risk as you can. So these are things you need to be thinking about as you're laying out these programs. All right, I just like this slide, so that's why I included it. But technology projects, there's going to be three things you've got to do and you've got to do well and you've got to account for. One is the technology itself, right? You've got to understand the technology, both today, where you're starting from, and then what's still coming in the future. What's the art of the possible? I think probably one of the most key aspects is change management. You're going to undergo a change. You're going to have people do things different. You're going to have to look at things in another light. Change has to be managed, and then effectively communicate. We talked, I think, a little bit, maybe John and yours, you talked about information and how people use it and what the expectation is. Well, what the C-suite needs, what the operator needs, and what the maintenance guy needs are three different things. And you've got to be able to talk at each of those levels and make it so that they understand why it's important to them, but why it's also important to the holistic company view and things of that nature. I promise you, if you don't do these three things well, your project's not going to be as successful as it could be, right? It's only going to be as limited as the one you're worst in. From a maintenance standpoint, we're going to build on our maintenance systems. There's going to be maintenance involved in this process using the building management system and all the things we're talking about. This is one I'm very comfortable with. I've worked with the company for a number of years. And it's called the Uptime Elements. And it's evolved. It was created in 2010. And it's a framework. It's of what you need to accomplish. It doesn't tell you how you have to do it, but it kind of gives you the end goal of where you need to get to in a variety of areas. And you can see the topics. It's evolved. In 2017, they added an asset management system, which ties very closely to the systems that are managed in the BMS. And in it took 17, they started it, but it got implemented in 20, is the digitalization sector. So now there's 6 domains that are included. And that center section, I think, is the most important. Well, it's important. It may not be the most important, but it's very high on there. But it kind of ties those two worlds together. How we're going to operate, how we're going to achieve. And it includes things like diversity and inclusion, sustainability. But then it also ties in the IoT side with the digital twin and the aspects that we're talking about as well today. So it's kind of, again, a holistic picture of how to bring this together. So you've got the information, you've got the systems that are working in the buildings, you've got your plans you put together, and then you've got your maintenance framework, that works all together. So what's the art of the possible? And I threw in one more slide, and I actually found this after I had done my presentation. And it's the Gartner Emerging Technical Impact Radar for 2023. And what's interesting about that to me is, one, that's the actual title. So if you go online, you can pull this up and read the article that went with it. Is it kind of lays out where things are today, right? What are the things, what are the tools, what are the technologies that we drive today? But what's going to be hot in a year or from now, 3 years from now, 6 years from now? I'll be honest, there are things on this list, I have no idea what they are. So I've got to go back now and learn and begin to understand. And there's a lot of them there that we've talked about today. But the themes for 2023 are a smart world, productivity revolution, privacy and transparency, and critical enablers. So again, things we've talked about today, things that we interact with, on a day-to-day basis. So it's an interesting read if you have a few minutes. All right, so the example that I was going to give you for JLL, there's 3 things here. One is called next generation maintenance. That's our interpretation of the uptime elements and how we implement those. I told you I operate, some technologies for the company. One of the things that we do is I operate within JLL. That was good. JLL proper. But then I also get to sell to the direct market, and I operate in the direct market. And those are really 2 different worlds themselves. In JLL, we have very prescriptive processes, procedures that are followed, name standardization, attribute standardization, things like that. So all the things that go into our systems are the same. So 80-85% of the things we do at all of our customers, very prescriptive. Direct, very specific to the customer. I sometimes equate it and call it the Wild Wild West. This example is in JLL. So we have those standards and things behind us, but we have a complete maintenance program from those standards all the way up to how you maintain equipment. In telecommand, we talked a little bit about earlier, but that's where we begin to take information and really optimize, whether it's real-time optimization, whether it's asset intelligence or machine learning. All these aspects begin to flow with the data like John was talking about earlier. And then Corrigo, which is our CMMS system, work management and things like that. So again, we tie all three of these together to operate the machines. So the customer we were working with was kind of looking for some specific things. Everything was smart BMS technology related as the RFP came out, or not the RFP, but the project scope. They wanted to be able to analyze equipment performance and detect issues. They wanted to easily be able to implement it at a site. The first application here was at a single site with, based on the results of that, a larger scope of project that would follow. They wanted savings on their O&M cost. They wanted to make sure they had global capability, and they wanted to be able to deliver other savings. So pretty standard stuff for an operating platform. Overall, what the project can bring touches on more than just that, right? Safety, maintenance, labor and maintenance kind of combined. Data we talked about, and I'm not gonna, I probably had more data conversation in this, but following the last presentation, I'm gonna say that's the gold standard and where we need to get to. But data is important. Overall knowledge, the vendor side of the house. That's something that gets excluded a lot of the time. But a lot of companies have to make a decision. Are they gonna have a technical force internal, or are they going to farm it out? So self-perform versus vendor perform. There's a cost associated with each one. One is more expensive than the other. So again, it depends on your model. And then energy. You know, everything around us will drive to energy savings. Will drive to, driving towards net neutral carbon consumption, and a lot of the goals, your corporate social responsibility aspects as well. So you can begin to tie together many aspects of your day-to-day business operations as well as your long-term deliverables. So where we start from today, you're always going to have a starting point, whether it's, like I said, that blank sheet of paper, or you've been operating for 25 years and you've got a lot of things to overcome. But mostly what we find is people still do frequency-based maintenance, at least partially, if not all of it. They're capturing running hours, maybe, and it's demand-based. And we want to get to, like I said, that proactive part, not the reactive part. So we want to get to predictive technologies. We want to be incorporating more and more of the uses in our BMS system. And what we find, both with BMS systems and CMS systems when we go in, people pay a lot of money for these systems, yet they never use the full capability. There's always aspects that are available to them. They don't need to use every aspect of the system, but I've never worked with a customer that couldn't use more of what they were already paying for and achieve a benefit from it. That's a key thing when you can talk to that's when you start talking about optimizing how they use it. When you can convince them that they can unlock potential in those systems that they hadn't done before. And then you see where we want to get to, the predictive. Again, a lot of the same things we've talked about. So in the IntelliCommand aspect and the account we were working on with those goals they had set up, it's really around detecting issues before they become issues. And it's about getting better at doing that, getting the information, getting the data, and then beginning to refine how you operate the equipment. And you can see there's 4 models there or 4 types that we look at. Run rule-based analytics. We put in a set of criteria and we operate to that criteria. We have, the cool thing about that is you can automate work orders within Corrigo, right? So the machine is telling me, hey, I need you to look at me. There's a problem, or there could be a problem. That's a cool aspect. We also have where you can interface with people looking at reports and work with the data and do the same thing. How many people have like predictive technologies. We do oil analysis, we do vibration analysis, whatever the case may be. We get these great reports with these great actions we take, and it's either digitally loaded and never looked at, put in a book on the shelf. This gives you that area where you can continue to build on that data, right? And continue to have that aspect front and center. The coolest one is the last one, which talks about real-time optimization, where it can physically make changes to the BMS system as it gains and understands and learns more about your system. That's when the world gets really cool. You don't need any interface. Now, most of the people I work with still want to maintain some controls. They're not quite ready to give up everything to a machine yet, if you will, or to a software. But we do that more and more, right? And so again, this is advancing quickly. Not only it's not the art of the possible anymore, it's the art of the reality. We can do that. A couple of other things you can begin now. Again, as you get more and more data, more and more information, this is where you begin to build machine learning and AI, and it's really like a snowball effect, right? So you've done all these other things to build the foundation. You've now got your systems aligned. Now we're beginning to look at the next steps. How can we continue to improve day by day, shift by shift, whatever the case may be? A couple of examples there. One, I don't have that, but in the top right-hand corner is what's known as the probability of failure curve. And reliability engineer here. But the probability of failure curve starts at installation, right? Funny thing is, one of the times that a higher percentage of the time equipment fails or has a fault right after installation. It's human induced, right? We didn't do something exactly right. But what this curve shows us is that once we put a piece of equipment or an asset in play in the system, over time it's going to degrade. It's going to change. Our operation is going to change. But what is it that we want out of an asset, right? We want an asset to deliver what we want it to deliver when we need it to. I don't need it to do it 100% of the time most times, right? And that started way back when the airline industries in the late 70s, early 80s, when they were having a ton of equipment failures. What's an acceptable equipment failure when you're in an airplane? I guess it depends if you're on the plane, right? But 99.9 is good. But that 0.1, what is the impact of it? And what this curve begins to show is you can actually begin to see the performance of a piece of equipment or an asset fade off, and you can tell when it's getting close to failure. You can take actions appropriately to mitigate that failure or make the decision to run to failure and things like that. So that's what the curve is depicting. Some of the RTOs or real-time optimizations, again, very much like the BMS system, right? You can do a lot of these things in there, but it's actually updating it. It's making changes, you're improving. Like I said, I started out at JLL, in the corporate real estate. I worked for one of their competitors early on, but I started in the energy and sustainability sector. And this was a few years back, so not quite as sophisticated as we are now. But one of the things we would always do when we were going into a customer is we would put sensors in the building. We would look at lighting and humidity and temperature controls, right? Because what we always found is there was a perception and there was a reality of what was occurring. They had building management systems and things like that. Again, not using it necessarily to the extent. So they would tell us how they ran their buildings. And then we would come and show the data of how the building was actually operating, right? And like I said, they didn't usually line up. The other thing, much like what Stuart showed with the lights on the building and the cyber attacks, was I would usually fly in, either the night before and take a picture, or if I was there for 2 days, take a picture of the building about 7, 8 o'clock at night when it was dark and most of the people were gone. And they would tell me how their lighting was working, and 60% of the lights would be on in the building with 10% of the people there. So these are the kind of things that it can continually update, right? And so there's a cost savings associated with that, and that's what's showing here for an air handling unit. Now the maintenance part, okay? So as we begin to look at the operation, it opens up, a lot of opportunity. And I'll just read the results, but we're looking at, whether we can do inspection. Any number of things we can do to improve the overall maintenance performance. So 48% of the tasks in this particular instance were moved to condition-based. 29, I love this term, tasks will remain at traditional intrusive PM activity, but now it's auto-generated, right? I still need to go in and do something. I need to replace a belt. I need to replace a filter, so I've got to break into that machine. But we still have to do that, but we're not doing it every 3 months. The other thing we would find is, again, people operate equipment the same. I live in Tampa, and you have a rooftop unit in Tampa, you don't need to maintain it the same way a rooftop building, a rooftop unit is in New York or Minnesota, right? There's differences, yet you go in and everybody looks at them quarterly, right? So 23% of the tasks are eliminated. Okay, you don't have to do it. And there's the benefits line up to the point we talked about earlier with the opportunities. So proof's in the pudding, right? This particular pilot was net to save about $240,000 with I think it's $76,000 in cost. We're waiting, we haven't quite got the 12 months of data yet to say definitively everything is what it is. What I will tell you is the savings are higher. The costs are a little bit higher too, and there were some reasons for that. We found some things they weren't doing that they in turn needed to invest in. But as soon as we get that, we'll publish those as well. But very positive, less than a year return on investment in these cases. And now it's something we can expand through their entire portfolio. And that's it. I do have a few others. I don't know if presentations get sent out after the conference, but if they do, there's some more detailed slides after this that kind of show different aspects of, some of the savings opportunities. Okay, that's it.
Yeah, so as you see, our mission is to elevate OT cybersecurity from art to a science to an engineering discipline. Okay, a little bit about ISA. We're a professional engineering society. We're kind of a corner case, hidden organization focused on automation engineering. Nobody really noticed us for a long, long time. It was started in about 75 years ago by a couple of boiler maintenance fellows who wanted to standardize the calibration of pressure and temperature sensors so they stopped blowing up boilers. So today we've published over 150 standards ranging from HMIs, flange standards, and alarm management, which is important. So we do education, help sharpen the saw for the engineers, do certification of technicians, publications, conferences. And in 2007, I was hired and we stood up a conformity assessment program to assure conformance to standards. After the 9/11 event, a group of forward-thinking engineers started the ISA 99 committee, which eventually published 15 standards and going on OT cybersecurity. They recognized that bad guys could tinker with systems, as was pointed out by some of the other speakers, and cause disruptions. In building automation systems, I think that if you turn off the life safety systems, fire detection and prevention, the fire marshal would probably say that you can't use that building. So there's a lot of things that can happen just in the building space with that. The 62443 series of standards are the most referenced standards in the NIST cybersecurity framework. And it was published as a technical horizontal, meaning that it's a standard that addresses technology. It's not sector specific. It can be used across sectors. So in 2021, the International Electrotechnical Commission, the IEC, designated 62443 as a technical horizontal standard. That means that as the different sectors, water, wastewater, electric, what have you, as they publish their standards, when they get to the topic area on security, cybersecurity, they're directed to start with 62443 standards rather than make whole bunch of parallel and duplicate cybersecurity standards. So, and the approach would be to put together a sector security profile, which is basically an application usage guide that says, here's how you use these standards for our domain space. Today, we're working with another organization called Building Cybersecurity, and we've developed a specification that will be used for assessing the as-built systems that are in the building automation sector. That'll be available. They're doing some prototype evaluations of buildings right now, but the formal program will be available early next year. The standard's being used in medical devices, the electric power sector. The DOE is funding the development of a sector profile, starting with substations and working into power generation, distribution automation, and distributed energy resources. It's also been adopted by the maritime sector. So there's two standards to address cybersecurity of onboard ship systems, and those go into effect January of next year. And the railways are using them as well, the zones and conduit model. So we've been certifying products since 2010, 2011 was the first certificate issued. We were way ahead of the market. We didn't do very many certifications early on. There just wasn't enough incentive to do it. It was voluntary adoption. There's no regulation driving it like a NERC SIP. But the standards certifications have really started to take off now. The 62443 is being picked up and referenced in regulatory language. So our program, we use a network of highly regarded ISO 17065 accredited certification bodies. They're the best of the best in the world. We have 10 certification bodies on board. They're big ones. They have like 20,000 employees and more. If you add up all the employees from the different bodies, it's about 200,000. So we've been certifying the commercial off-the-shelf products since 2010, 2011. In December of this past year, we issued an IIoT, industrial IoT product certification. So we're doing devices and gateways. We have a study that's ongoing now to look at the full technology stack for IoT. Buildings are probably the most connected of anything to cloud providers. And so we'll do a certification that involves cloud providers all the way down to sensors, actuators. So certifications available today, IIoT components, other components. The standard defines components. There's 4 categories: application software, network devices, embedded devices, and host devices like Linux and Windows workstations. So pretty much everything falls into that. It's a roles-based standard, so it has 15 sections. There's a few sections that are for suppliers and manufacturers. There's a few sections for system integrators and service providers, and a few sections for the asset owner operators. We're now looking at them, and we see there's a missing role, which is cloud provider. And the cloud provider can have 4 or 5 roles with that. There's like SCADA and control systems in the cloud. There's reporting systems. There's just hosting. So that's being considered as we speak. So certifications require conformance for product suppliers. It requires conformance to a security development lifecycle standard. So the suppliers their development practices are assessed, and they need to conform to this 4-1 standard that has 8 practice areas in it. Things like secure by design, testing and validation, playbooks for addressing the vulnerabilities that are found and communicating to your customer, that sort of thing. It's not a once and done certification, so you get products certified, and Then there's a maintenance of certification. You know, as you do go through version releases or patches, assumes that your products are under configuration management, and all these processes are done in a controlled fashion. So these are the two new certifications coming out: the IoT system security, which includes a cloud provider, and the site security assurance. Like I said, it's going to come out Q1 of next year. There's two versions of it. One is specific to building automation technology, and the other is going to be specific to production facilities. So this standard and the certifications will be able to be morphed to address other sectors. So that'll be our baseline certification. We can use it for transportation, water, wastewater, other sectors. So this is just the timeline for our building automation product certifications. We started the certifications in 2010. In 2016, I recognized that the building automation was an important dimension of our everyday lives, and it's probably something we should be looking at. So we did a study to determine applicability of the 62443 standards to building automation. We had companies like Johnson Controls, Siemens, Honeywell, others, some asset owners. They all contributed. Today, their consortium that develops and oversees this conformity assessment program, it started with a lot of the oil companies and process automation providers. Today we have the building automation providers have added in Johnson Controls, Carrier Corporation, Honeywell, Schneider Electric, all the majors. We're adding Train. Products have been certified by many, many companies, all the ones I mentioned, Otis Elevator. So we're developing a pretty good footprint in this in this sector. So I'm not going to repeat here. So one key thing with the demand levers for certifications, typically it's either a regulation or it's written into procurement specs. So an owner investor, requires the products that are being installed be secure, or insurance companies like with cars. And so we're partnered with this organization, Building Cybersecurity. They're working with the customer-facing dimensions of this certification. They're working with Aon, an insurance company, to provide insurance incentives for owner investors of buildings to have their building automation systems secure. They have 4 levels of security. The standard itself defines 4 levels, and so we've applied the standard's 4 levels to what makes sense for the building automation systems. So that's unique. There isn't any laws or regulations yet, but that's the demand lever for it. Let's see. Yeah, see, these are some of the supporters. We picked up Amazon Web Services, so they were interested because of the cloud provider dimension of our certifications coming out. But you can see the, let me go back one. Yep. I won't go into detail on this, but these are the standards, and they're organized by role. So the standards are organized role-based: product suppliers, integrator, service providers, and asset owners. So you see the 3 big boxes, and next year I'm probably going to add a box called cloud provider. And the standards committee is doing the same. We've partnered with a bunch of companies to develop the studies and reports for how to apply the standards. And based on our studies, they're all published publicly. There's lots of links to great information. It's on my last slide. These slides will be available to everybody. Let's see what else. I'm not going to go into the value of certification, but just some more details. We use, it's a button-down program. These are accrediting authorities. So these independent accrediting authorities use our recipe for accrediting and the qualifications of assessors, et cetera. And then they accredit the certification bodies. And one of the things you'll notice, one of them is FM Approvals. They're a subsidiary of FM Global, which ensures big assets, particularly in the manufacturing industry. So as they start developing their portfolio of certified products and systems based on our standard, that'll be a basis for them qualifying companies to have their products insured. So there's 4 levels. I mentioned that. We're recommending that companies certified at level 2 or higher. Level 1 is like inadvertent cyber incidents. Level 2 is the first level at which you're protecting against intentional attacks. So we're collaborating with a lot of organizations. North American Transmission Forum is one. Logic, it's Oil and Gas Consortium. Building Cybersecurity, and OPAF. This is just a list of companies that have had products certified. So, you know, it's a who's who. ABB, Osbil, Carrier, Cisco, Eaton, Emerson, GE, Generac joined recently. They haven't certified yet, but they're going to. Hitachi, Honeywell, Rockwell, you know, you can see them all. This is what we certified last year. The left side is their security development lifecycle. Some of these companies have multiple sites certified, some are global, some are in the recertification process to maintain their certs for their development. And then system level certifications in the middle. These tend to be bigger, more expensive, and then components on the right. You can see Johnson Controls, Honeywell, and some others. So there's the resources. So I oversee 4 consortiums, the Security Compliance Institute, ISA Global Cybersecurity Alliance, which is doing promotion of the standards and developing training material, education, etc. So anything that related to cybersecurity for building automation and just automation in general, you can find here. So that's it.